Number 6, let f be a differentiable function with f of 3 equals 7 and f prime of 3 equal negative 9, and let g be the function defined by g of x equals 2x f of x. Which of the following is an equation of the line tangent to the graph of g at the point where x equals 3? And we will use a hint. You will need to use the product rule at some point in time. All right, first of all, let's look at, we would like to find an equation of a tangent line. So I know when I am done, I will have something that looks like y equals mx plus b. All right, so what we need to do is we're going to find m, we need to find the derivative, and then we'll find an x and y value, and then we'll finish from there. So we're not finding the equation of the tangent line of f, even though they give me information about f. We want to find the information about g. So I notice that g of x is equal to 2x f of x. That is a product because it's 2x times f of x, so that's where we're going to use our hint and use the product rule. This is going to be a little confusing, but I'm going to use f and g. Okay, f prime is going to equal the derivative of 2x will be 2, and then g prime, the derivative of f of x will be f prime of x. All right, so if I'm taking my derivative, using the product rule, f prime times g, I'm going to have 2 f of x plus f times g prime, 2x times f prime of x. All right, and it did say that we were going to find it at x equals 3, so now I'm going to find g prime of 3 by actually plugging 3 in for all of my x's. And now you'll notice this is where we're going to use the information that they gave us up in the first sentence. We know that f of 3 is 7. We'll get 2 times 3 times f prime of 3 is equal to negative 9. And if we work that out, we are going to get that g prime of 3 is equal to negative 40. What that has found for us is the slope. All right, so we now have y equals mx plus b. We know that the slope is negative 40. I also know my x value is 3. And my y value, we might be thinking that it's 7, but that's on the f. We need a y value of g, so I need to find g of 3. So I'm going to use that original formula they gave me for g. It would be 2 times 3 times f of 3. So I'm going to have 2 times 3, f of 3 again was 7. So g of 3 is equal to 42. So my y value is 42. So now I can just work it out from here. So I'm going to have 42 equals negative 40 times 3 plus b. I'll get 42 equals negative 120 plus b, and that will give me b is equal to 162. So I don't need to circle that. So I'm going to have y equals negative 40x plus 162. An alternate way to write this answer would have just been y minus the y value equals mx minus the x value. So that would have been an alternate way to write that answer. Number 7, the graph of the derivative of a function f is shown in the figure below. The graph has horizontal tangents at x equals 2 and x equals 6. We definitely can see that there are horizontal tangents there. Good for us that we know that. And then at which of the following values of x does f have a relative minimum? Well, we know if we're dealing with minimums, we want an f prime chart. So when we're making an f prime chart, this is f prime. So f prime to f prime, we're just going to be looking above and below. So I notice that the derivative is above the x-axis till I get to 0. It stays above until I get to about 4.5, it looks like. And then it stays below until I get to seven. And so, well, it stays below. Actually, guess what? I did something with this chart wrong. Let me figure out what. Okay, it stays above. Okay, below. That's what. Okay, negative, positive, negative, positive. There we go. I was getting a little confused there in what I was doing there. Okay, so it stayed below, and then above, and then below, and then above. All right, and so if they're asking for relative minimums occur where f prime changes from negative to positive. So if I'm looking for where does f prime change from negative to positive, that would be at 0, and that would be at 7. So you'll notice my choice would be D. All right, number 8. The radius of a sphere is decreasing at a rate of 3 inches per second. At the instant when the radius of the sphere is 9 inches, what is the rate of change in cubic inches per second of the volume of the sphere? So I notice that this is a related rates problem. So since the radius of the sphere is decreasing at a rate of 3 inches per second, we're going to have dr dt equals -3 because it is decreasing. Then it says at the instant when the radius is 9, so r equals 9, what is the rate of change in cubic inches per second of the volume? So we want to know dv dt is our question mark. And they did already tell us the units would be inches cubed per second, so we can remember that when we are done. All right, so I'm going to start with my volume formula. We know in a related rates problem, we're just going to take the integral of the derivative of both sides. The derivative of v would be dv dt, and then the derivative of the right side, bump my 3 out front, I'm going to have 4 pi r squared dr dt. Okay, now from here we're just plugging in information, so we have dv dt is equal to 4 pi, the radius was -3, we're going to square it, dr dt, and then we can leave the pi in there if we want. If we left the pi in there, we are going to end up getting, whoop, I did something wrong here, this was the radius, 9 squared, and then our dr dt was -3, sorry about that. Okay, so then when we work that out, we will either get -972 pi, or if you worked it out to a decimal, it would be -3053.628, and my units would be inches cubed per second. All right, number 9, find the limit as x approaches 5 of 3 minus the square root of x plus 4 over x minus 5. This is a calculator section problem, so I don't need to try to do anything algebraically. There's 2 ways to do this. We could either draw a graph or we could make a table. I tried doing a graph and it really didn't do anything for me. I couldn't tell what was going on, so I'm going to go straight to the table for this one, and I'm just going to find things close as from the left and the right. So 4.9, 4.99, 4.999, and then 5.001, 5.01, and then 5.1. And then I went to my table feature and found those out. I got -0.1671, -0.1667, -0.1667, -0.1667, -0.1666, and then -0.1662, I believe. All right, and so I can tell as I'm coming in from the right and coming in from the left, I am reaching to 3 places, -0.167. And if you notice, that is actually the fraction 1/6, but either one of those would be acceptable. Okay, problem 9. If y equals 5x minus 4 over 4x minus 5, then the derivative is equal to what? Notice even though that this is on the calculator section, I really don't think I can use my calculator to get an answer. So I notice that this is a quotient, so I am going to be using the quotient rule. So this is my f, this is my g. F prime would be 5, g prime would be 4, and now I'm ready to use the quotient rule. Okay, and depending on who you had last trimester, I'll try to say it both ways. I like to do f prime times g, so 5 times 4x minus 5 minus f times g prime all over g squared. And I know Mrs. Gagan did high d low minus low d high all over low squared, so that is totally fine as well. All right, and then I'm going to distribute. I'll have 20x minus 25, and then in the next part, I'll have negative 20x plus 16. Be careful on that one because that does distribute to both parts when we're doing that. And then this is still all over 4x minus 5 squared. The 20x's are going to cancel, and negative 25 plus 16 will give me -9 over 4x minus 5 squared, and that will be my